Welcome to our workshop. My name is Kirival Kongsgaard. I work for DNB's Cyber Defense Center on topics related to detection and response. In this workshop, we show how to build custom tools for memory forensics by combining the framework volatility with the Python data ecosystem.
My name is Anya Olsen. I am a detection engineer and incident responder at DNB along with Kyrre, and I'm excited to be on this workshop. We're going to be treating memory forensics problems in this workshop, and that is a field of expertise that you actually really need sometimes during incident response processes because not everything on the system is logged and not everything can be solved with live tools or EDR. So you sometimes have to resort to the closest thing you have to a source of truth on a system, which is its memory. It is a difficult art to master, however, so that is why we saw the potential to include some modern tools to make it easier to automate and more accessible to more people. We hope you find it useful and that you enjoy the workshop.
Volatility is a popular memory forensics tool. It's a plugin-based framework, so the way that the analyst usually interacts with it is via the command line. So there is a plugin for extracting the processes that ran on the system when the dump was initiated. There's another plugin for listing the DLLs that these processes imported, and there's a plugin for example, for extracting the files from the file cache and writing them to disk. If you're a Unix wizard, then working on the command line isn't an issue. You can take the output from these volatility plugins and pipe them to a sequence of Unix tools to extract just what you need, or you can use, for example, the CSV render to export the data to, say, a spreadsheet. Volatility has recently added support for writing the output of plugins to the Arrow and Parquet format. Now, this is a big deal because this is the same data formats that the modern data ecosystem is built on top of. So this minor change is what allows us to bridge the forensics and data analysis worlds, which is exactly what we will explore in the remainder of this workshop. So what we're actually doing here is recasting memory forensics as a type of data analysis task, and then we are tapping into the Python data ecosystem and using it to build interactive tools, visualizations, and data apps that process the output of these volatility plugins. So in practice, what this means is that you can now extract the list of processes, the list of DLLs, the list of network connections, and import those into tables in your database. And then you can continue by transforming them, modifying them, or joining them together. The approach we take in the workshop is to use the Marimo notebook as a development or data analysis environment, combining that with DuckDB as a query engine or database. And then we use the IBIS data frame library to express queries that execute on DuckDB. The outputs from volatility plugins are then exported to Parquet files, which are then read from DuckDB and stored as tables. By combining these tools, we show how Marimo's reactive execution model, its support for UI elements, AI features, and custom visualizations allow us to create bespoke investigation environments, and how it allows us to build task-specific data apps. For example, an initial alert triage dashboard, tools for searching through the string contents of a memory dump, or a complete interactive environment for writing and testing YARA rules. We have organized the workshop around a collection of hands-on notebooks that each treat a separate topic, ranging from Marimo, IBIS, how to process volatility data, to building custom visualizations. Before we jump into these notebooks, we have a short section that demonstrates how to use volatility on the command line. It showcases some of the more commonly used plugins and how to write Parquet to disk.
Typically, the very first time you try and analyze a memory dump, it's probably not an incident, but it's more like you're just trying to learn it a little bit and see how it works. And at least for me, what I did the first time was to go and find some CTF online or something, download the memory sample, and then just follow the walkthrough after trying a little bit first, obviously. Uh, so you're probably familiar with the existence of the volatility framework. I'm just going to show very quickly a couple of plugins just to show you how it looks like in the command line, because all of these walkthroughs that I mentioned, they typically just do the command line commands like this, and then you output the output to a file in plain text, just like I have read in the command line here. This first one, PS list, is going to show the processes on the system and list them out with some information about each one. I'm not going to dwell too long on this. I'm just going to run it and then show you the output. It does take a couple seconds, but not that long. So let's see what it looks like. So here you can see the output of that plugin. Typically the workflow would be to just scroll through it. If you're looking for something in particular, you could grep for that. SVC host, for example, and you will get all the SVC host processes. This is fine, but if I show you a different plugin called Malfind, you're going to see that that's increasingly difficult to work with just in the terminal like this. So if I go ahead and I run the Malfind plugin, that's also, it often comes up in the walkthroughs that I mentioned. If you're new to memory forensics, we're gonna have a lot of time with this plugin output throughout the workshop, but this is just an initial view of the raw output in the terminal. So since this is a recording, you didn't have to wait around for that, and then we can go ahead and explore the output now. So yeah, this is what it looks like. It's not necessarily that easy to extract the information you need from this. I'm not going to dwell too long on this, but what you would have to do would be to kind of grep through it. Execute, read, write, for example. Then you would only get the lines that contain that. Needless to say, this is not ideal. There's a better way to do this, and we're going to get to that soon. My colleague and co-host for this workshop, Kyrre, made a contribution to the volatility project that allows you to export the output to Parquet using this -r Parquet option here. It's going to be part of one of the next releases of the volatility project, but until then you have to use something like this where you actually get the code from GitHub to run that option. And then you just pipe the output to a Parquet file, and that's what we're going to work with for the remainder of the workshop. And you'll see how nice that is shortly.